So just a very short introduction. As you can see, my name is Agresa, and currently I am an assistant lecturer and a PhD candidate at the same time. I studied math and I love that, so that's why I'm now still doing it. So it's been about 6 years teaching in university and trying to apply math in different fields as my PhD topic, which is related to machine learning models in energy systems. So it's been a very incredible time studying math and doing math now. Here at R Ladies Tirana, we are a very great and incredible team. I'm going to introduce the team a bit later. And together we organize some very interesting events, and we have some very interesting ones in upcoming months. So, part of the team here is Arnisa, my colleague.
Hello.
Yes.
Can I introduce myself or will you
Please,
do
if
it?
you want to say something
Okay.
about.
Okay, thank you. I'm Arnisa Sokole. I'm also an assistant lecturer at the University of Tirana, and I'm currently doing my PhD at the same university. My background is in applied math, so I have studied mathematical and computational engineering at the University of Tirana, both bachelor and master. And now my PhD is also in machine learning models and time series models with multivariate time series. So we share the same interests, and
Yes.
so we do implementation of different data sets and problems of real life into softwares like R and Python.
Yes. And also part of our team is Professor Eralda. She's here. Hi. Is
Everyone.
Lula also, Marisa. They are also part of Our Ladies Tirana team. And I think it's now time to share something about the team and what kind of activities we have been organizing. Okay, I think you can see my screen.
Yes.
So, Our Ladies Tirana, let's say, it's a new chapter. We have been around for about a year and 2 months. And during this time, okay, let's start from the beginning. So, Our Ladies Tirana is part of Our Ladies Global, and Our Ladies Global is a very big and huge organization, and it's dedicated to promote studying or applying R as a programming language, but not only R. So as you have seen today, we are here to implement linear algebra topics in Python and R at the same time. So us as a team, we provide a supportive space for learning, collaboration, and knowledge sharing. Our Ladies Global is, as I said, a very big organization, and they have chapters in more than 200 cities around the world. If you want, you can also find chapters, for example, Our Ladies Rome or Our Ladies Paris or Our Ladies London. In different cities, they have different events, so you can join them online or even on site if you are there. And I think that you are going to have a very great time with them and to learn, because this is a space for everyone who wants to learn something, to share something, and we definitely are open for everyone who wants to organize a session or even an open lecture to share something from your background expertise or something that you see that it's very interesting to share with others. So next slide. It's not moving. I don't know. Okay. Our team, as I said, we are a team of girls. Currently, we are open to every single man who wants to join the team, because Our Ladies, it's definitely, as you can see, Our Ladies, and you say, okay, it's probably only for ladies, but no, it's not only for ladies, it's for everyone. So if you want to be part of Our Ladies and you are um, ready to share something or to learn or to grow together, you're more than welcome to join us. So let's introduce, I'm going to introduce some of our previous events. We started some previous events related to Introduction to R and Data Science with R. We have 2 series currently. The first one is From Zero to Hero series. And in this series, we're organizing, for example, some open lectures related to R, implementation, coding, data science. And another lecture, open lecture session was setting up R and R Studio environment. We are talking here for the events from the last year. Another one, and the biggest one, was the Power 2025 related to Data Science, AI, and Technology Summit. It was a very incredible summit for 2 days here in Tirana, and in this summit, we had 26 speakers from around the world, and they shared something from their job, something related to AI, applications, and technology at University Metropolitan Tirana, Albania, but definitely they have access online to share and to present or participate in this summit. Another session we had this November. It was related to basics of graphs and networks in Python. And okay, these sessions or these events are part of From Zero to Hero in R and data science, but we have also another series, which is Spark series. And in this series of lectures, we are going to organize, for example, events not only for data science, not only for coding or implementations, but we have here some interesting topics related to leadership, related to motivation, and some other topics that you are going to see in the upcoming sessions. So you have so many reasons to join us. As I said in the beginning, if you want to share something, if you want to join, if you want to listen, or if you have any project that and you want something to implement in Python or in R, you're more than welcome to contact us. Definitely, R Ladies Tirana, part of R Ladies community, is dedicated to share this supportive and inspiring environment, and you're more than welcome to be part of this community. You can find us in our socials. You can find us in Instagram, in LinkedIn, in Meetup, where we have been publishing events, sessions, or information, or something related to informative posts, to Python, R, and some other, let's say, conferences, events, and everything related with this kind of topics. So now I think we are more familiar. So I'm going to stop my screen here, sharing my screen here, and let my colleague to continue with our sessions, our today's session.
Session, yeah.
Yes.
Thank you, Agresa, for all the information that you have shared. I will start sharing my screen. So I will share my entire screen since I will present. Okay. So can you see it? Okay, thank you. So I will start with today's session. We will see how core concepts of linear algebra are applied directly using R and Python. We will not only understand the mathematical definitions, but also we will see how vectors, matrices, linear transformations, and systems of linear equations are handled directly into softwares like R and Python. Linear algebra provides the mathematical foundation for data science, statistics, machine learning, and optimization problems. That's why it's so important. So about vectors, vectors are the most basic objects in linear algebra. A vector is an ordered list of numbers, and vectors can represent measurements, coordinates in space, and features in a data set. Vectors in R and Python are one-dimensional. All the elements must have the same type. We will So we will define today only numeric vectors, but we can use examples also with character vectors and logical vectors. In R, vectors are the basic building block, while in Python we need to import some packages in order to define vectors and also to make some manipulations with vectors. Some vector operations are shown in the table. So these are all math operators for addition, subtraction, element-wise multiplication, and dot product. These operations are essential in geometry, statistics, and machine learning algorithms. Later on, we will continue with some examples in matrices. A matrix is a rectangular array of numbers. Here we define the dimensions of matrices, so the number of rows and the number of columns. And matrices are used to represent systems of equations, data tables, and linear transformations. In R and Python, matrices are two-dimensional. In R, all the elements are placed column-wise by default, but we can change that, and all the elements must have the same type. Matrices are essential for linear models and multivariate analysis. Some common matrix operations, we have the same math operations as before, so the ones that we use in vectors, so addition and subtraction and also multiplication if we perform it element-wise, but we have also some other math definitions, for example, for matrix multiplication, which is different from element-wise multiplication. We can also compute the transposed matrix of our matrix and also the inverse when it exists. But each operation has its specific mathematical rules. And the next one will be the systems of linear equations. In a matrix form, they can be written as the multiplication between the matrix A with the vector of unknowns, which results in the vector of the constant terms, which is B, and here we have its matrix form. In order to solve linear systems, the matrix A must be square and the determinant of A must be non-zero. These solutions are fundamental in engineering, economics, and data modeling. So all these concepts we will be presenting live in R and Python. I will start firstly with R. We have presented in our previous session the environment of R and R Studio, and how we can code in R. We can use scripts, or maybe we can write in console for basic mathematical operations, for example. But here I will be presenting our the session here with vectors, matrices, and systems of linear equation in a new file, which is R Markdown file. Maybe some of you are familiar with that, but in general, this file is used in order to write text, so to write interpretations, for example, of our results or our graphics that we can show, and also we can write formulas here with the LaTeX style and also perform the code and execute the code. I will start with creating vectors in R. The basic function that we use is the C function. So we can write V, for example, which will be the name of the vector, and equality sign in order to assign the values to the vector C. The function C here is used with round brackets, and all the elements are separated with comma. For example, we will have a vector with elements 2, 3, 5, and 9. And we can print the result below if we click the Run button here. We also have the sequence function in order to create sequence numbers, so a sequence array with numbers. The sec function is used in the way that, for example, x equals sec, and here we have 3 parameters. The first parameter is from, for example, from 1. So it's the starting point of the vector. Then we have 2, which will be where we want to end our sequence, for example, to 9. And by default, we have by, which is equal to 1. So the step from which we pass from one element to the other is 1, but we can change it. For example, we can write another number, if I can say, for example, here 3. And we can print the result. If the last element, so if we have the incrementing step with 3 and we don't arrive at the final point, we will not print it. But if we want all the elements and we want to define the length of the vector, for example, the vector u, we can use another parameter, for example, from 1 to 9. To 9, we have length dot out, which will be, for example, 9. And we have, we will print also. Okay, I forgot the equality sign here. And here we can see all 2 vectors. The next function is rep, which means that we replicate elements of the vector. If we have, for example, the vector v, and we want to replicate each of the elements, for example, a specific amount of times, we use rep v, and then each will be equal to, which means that each of the elements is repeated 2 times. But if we use rep, for example, v, and we define another parameter which will be times, and we write, for example, 3, it means that the whole vector will be repeated or replicated 3 times. So we have the vector 2, 3, 5, 9, again 2, 3, 5, 9, and 2, 3, 5, 9. Another operator then we can use in order to define or to create vectors is the colon operator. If we want if we use this operator, the elements will have the step 1. So they are separated from each other with the step 1 and or -1. It will be based on the first number and the second number that we use in the colon operator. So I can write, for example, A will be a vector with the elements from 2 to 10. And we create here a vector in ascending order, and we can print A. But if we want to write in a descending order, we can just write the larger number, the greater number before, and then the second one will be smaller than the first one. Okay, I will have to print also B here. And the last function that I will present in the section of creating vectors will be the sample function. This function is used in order to select randomly some values from a previously created or from a vector that we define into the sample function, into the parameters. For example, W equals sample. We have some parameters here. The first parameter will be the values from which we want to take these random values. So for example, from 0 and 1, we want to create a vector with values of 0 and 1. The size, for example, will be 10. And also, since we want to repeat the number 0 and 1, we have to write replace equals true. And then we can print the result. Okay, so now we have a table here with some arithmetic operators, which we can use in order to make some math operations. Firstly, we will start with mathematical operations between vectors and scalars, and we will use all the syntax that is shown here in order to perform addition, subtraction, multiplication, division, etc. So firstly, maybe we can use one of the previously created vector. For example, I can use the simplest one, which will be the vector v. And we can perform addition with a number, so all the elements will be added, for example, the value 2. If we don't store it in a variable, we can see the result directly into the output section. Later on, we can define subtraction with the minus operator, so v minus 3, and the result will be the vector here. If we want to perform multiplication, we use the asterisk operator. So, for example, v times 2 asterisk 2 in order to create a vector with all the elements multiplying by 2. Division, so we have to use the slash operator. So, for example, divide v by 2. And here we have created a vector with floating point numbers. If we want only the remainder of the division or the module, we will use the double percentage operator or symbol. And for example, I can use the same scalar, which will be 2. And if we want to know the integer division of all the elements of the vector v with the number 2, we can write percent slash percent and then 2. And this will be the resultant vector. Now, if we want to perform all these operators between vectors, we have to be sure, firstly, that the vectors will have the same length. Maybe we can use the same vector v and also a vector u with values from 1 to 4. We can check the length of the vector u and the length of the vector v, and the result must be the same, so it's 4. Now we can perform addition, so v plus u. These elements are performed element-wise. These operators are performed element-wise. We have also subtraction, for example, v minus u. Element-wise multiplication will be v asterisk u, since this is the operator that we use in order to perform multiplication. And division, for example, v divided by u. And we have the resultant vector here. But one of the core concepts in that is used in vectors is the dot product. The dot product of two vectors is defined with the formula here, and the result of this operation will be a scalar, so a number. So if we take into account the same vectors v and u, they must have the same size, and we can define the dot product, which will be with another syntax, which is percent asterisk percent u, and the result will be 59. Now I will continue with matrices. Matrices can be seen as a collection of vectors. In order to define a matrix in R, we need to firstly know the elements that we want to place into the matrix, so the data, and also the number of rows and the number of columns, which is very important. In order to distinguish matrices with vectors, I will use now capital letters. So M will be a matrix. So here we use a matrix function. Matrix function is part of the base package in R. And the first parameter is data. So I will create a matrix with values from 1 to 12, for example. Now I will use the number of rows. So in order to define the number of rows, for example, 3, and the number of columns is defined automatically. If I don't use another parameter, all the elements will be placed by columns. So I will print the matrix M here. And you can see that the elements are placed column-wise. If we want to change that, we can use a parameter which is by row. By default, this parameter is false, but we can change that into true. So, for example, n will be a matrix. I can use the same values in order to see the difference between these two matrices. So the number of row will be 3 and by row will be true. True and false are Boolean or logical values, so we need to define them in capital letters. And n now we have the dimensions the same since we have defined the number of rows the same, but the elements are placed in another order. So we have placed the numbers here by row. Now we can use all math operations that we performed before with vectors, also with matrices, and we will start with, I will start with matrices and scalars. So if I have the matrix M, which I previously created, we can perform addition with a number, so all the elements will be added the number 3. And the result will be a matrix with the same dimensions, but the elements will be added the number 3. Now I will continue with subtraction. So we can use the same one and we can perform subtraction. And we will get the resultant matrix. If we do multiplication with the scalar, we have, for example, me asterisk 4, and all the elements will be multiplied by the number 4. Also, we have the power operation, which is performed with a hat symbol. I can use here the hat symbol 2, so all the elements will be in the power of 2. And also the division, for example, divide by 3. And we have here floating point numbers. If we want to perform elements between two matrices, all the operations are performed element-wise. Also, we can perform element-wise multiplication, but it is different from matrix multiplication that we know from math. So I have the matrix, maybe we can use the same matrices that I created before, so the matrix M and also the matrix N, or maybe I can create two other vectors, other matrices. So A will be a matrix with elements, for example, from 1 to 9. The number of row will be 3. And I can let by row false, so the elements will be placed column-wise. Now B will be a matrix. I will take a very simple example with the elements from 10 to, for example, 19. And the number of row will be 3. We can print these two vectors here, two matrices. Um, so I have to, okay, I have a mistake here. Mistake here. Now we have two matrices with the same length, and So I needed to start from 11 to 19. But from 10 to 18, we have these two matrices here. And now if we want to perform addition, we will do just A plus B. And this will be the resultant matrix. If we want to perform subtraction, from B minus 1. Okay, so all the elements must be the same here. If we want to perform element-wise multiplication, we will use the same, so we will use the operator of asterisk. And here we have element-wise multiplication. If we want to perform division, we will use the slash. So the slash operator. Now, I want to emphasize again that the matrix multiplication is not the same as element-wise multiplication. In order to perform matrix multiplication, the inner dimensions of the two matrices must match. So if I have a vector, so a matrix, once again, so I can use the matrix here, or maybe I can create a matrix C, which will be with elements from 1 to 6, and the number of row will be, for example, 3, and we can print the matrix okay. Maybe we can write some numbers here for 8. And then number of row will be, for example, 2. And then C. So here we have the matrix with dimension 2 by 3. If we want to perform matrix multiplication, we need to have the inner dimension the same. So this is 2 by 3. The next matrix, which will be, for example, D, will be a matrix with values, for example, 1, 3, 5. Then 7, 8, and 9. And the number of row will be now 3. And we can print also the vector D, the matrix D here. Now we can perform matrix multiplication, which will be with the operator percent, asterisk percent, and D. Okay. I have here seeing capital letters, so we have here the matrix multiplication. If we want to define the transpose of the matrix, so we want to swap rows and columns, for example, we can use the T function, TC, for example, and we can see here that we swap rows with columns. In order to find the determinant of a matrix, for example, I will have a matrix A with values 2, 4, 5, and and 1, and the number of row will be 2. If we want to find the determinant, we need to use the function that. And we have the determinant, which will be minus 18. In order to find the inverse of the matrix must be a square matrix with a non-zero determinant. So for example, we can use the inverse matrix of the matrix A, and we can write A inverse, which will be with the function solve E, and we can print later the result. And here we have the inverse of the matrix A. In order to define an identity matrix, we can use the function diag, and we can write, for example, 4. In this case, we will have an identity matrix with dimension 4 by 4. And also we can write here, we can see the example if we multiply the matrix E with its inverse, with matrix multiplication, and the resultant will be a 2 by 2 identity matrix. In order to solve linear systems, we can write it in a matrix form. As I explained before, A is the coefficient matrix, X is the vector of unknown, and B is the vector of constants. We have an example here, short example, and in order to find the solution, we will use the solve function. But now we will put two parameters, so the matrix A, which will be the coefficient matrix, and have the values 2, 1, 1, 3. The number of row will be 2, and by row will be true again, since I placed the elements by row. Here we have the matrix A, and also B, which will be a vector with the elements 1 and 2, and we can print also the B vector here. So we have the matrix A and the vector B. In order to solve this system, we will use the function solve, which is a part of the package base package in R, and solve A comma B. We will get the resultant vector. We can also see, so we can compare the result if we write, for example, X will be the inverse of A, so solve A, and we perform multiplication with the vector B, and we print the result. We have the same vector of unknown. So this is all about linear algebra in RAM. Agresa will start, I think, with Python. And I will leave the floor to you. I will stop sharing. If you have any question, you can write in the chat, or maybe at the end of our session.
Yes,
Thank
okay.
you.
Well, thank you so much. It was a very interesting presentation, and I think everyone got a bit about R, environment, and how can you create and work or manipulate the vectors, matrices, and try to solve something related to systems of equations. So, okay, we have just 20 minutes, but I'm trying to finish on time. So first, I don't know, what can you see? I think I shared the wrong I'm going to share this one. Okay. Okay, now you can see my screen. So, continuing the previous knowledge that Aranisa shared with vectors in theoretical side or even in the practical side, I created here a very easy and simple, let's say, examples related to linear algebra. In Python, we are going to work in the NumPy library, and the NumPy library is here. You can check it. It's numpy.org, and here you can find the information about the library, how can you install it, and something related to documentation, versions, and everything related to the knowledge from theoretical side, but also from the practical side. For example, if we can open documentation or learn, for example, here documentation, you can find everything related to NumPy as a library. And here is the guide for the absolute beginners. And there is also for people who has knowledge. So NumPy for the absolute beginners, basic for beginners. You can start from here. You can even copy and paste these cells here. And you can manipulate or try to adapt your problems in Python. So you can see here that there are so many tutorials, materials, and information about this package. This is the main package when you can work with data and tables. You can manipulate vectors, but there are also some other libraries. For example, pandas or other libraries where you can manipulate or create the data or data frames. So let's go back here. So this is the my Jupyter notebook environment. I would love to create here forever since I discovered this because you can definitely work from here. You can definitely code in some other environments such as Visual Studio Code. So first of all, we have to import the library because the library has the background related to all the linear algebra concepts, but definitely some, let's say, concepts beyond that linear algebra. So we can import NumPy as NP, and then you can see here, because in the upcoming cells, we are going to see something related to linalg, which is an abbreviation for linear algebra. So if we can, for example, see here what is this directory, we can see that there are so many packages and equations or functions related to linear algebra concepts. For example, you can see here determinant, you can see eigenvalues, you can see eigenvectors, the inverse matrix, determinant, and the solutions to system of equations, for example, related to linear algebra concepts. So vectors in Python, we can declare them as arrays because definitely Python is it's known that and NumPy it's known as a library of arrays. In this case, for example, we have U as a NP because we are in this library dot array, which means that we are talking about a vector or we are talking about an array. So here we have U and V, but definitely we can create, for example, some other vectors. Z in this case is NP that ones. For example, the vector with ones, no, this one, 11. And okay, we have to print it. And we can see, for example, the vector with ones, or we can see, or we can create the vector with zeros. And we are expecting to have a vector with a dimension 11, and all the elements are going to be 0. And definitely we can create other vectors as a range between, for example, 0 to 10 with a step 2, or the vectors that Arnisa created before. So another function from the NP or NumPy library is the shape. For example, here we have the shape of the vector, or the dimension for the vector O, but for the vector Z it's 11. And about the norm or the magnitude or the length of a vector, as we know as a square root of the sum of the square elements or the coordinates of the vector, it's easy here because we do not have to do all these calculations for a vector, but from NumPy library, we can take NumPy apart from linear algebra concept, the function norm for the vector u. In this case, the norm of the vector u, we can find it and we can print it. It's 8.3 because the vector u is the one we created here. Okay, about the addition, about the subtraction, about the scalar multiplication, these are the basic concepts even with vectors. If you previously create vectors, then you can definitely add them. If you can also subtract them, or you can do some other math operations with vectors. For example, here we have S equal to U plus 2 times V, and we have to print the vector S, which is the result here. About the subtraction, the vector D is in this case the difference between U and V, or you can do, for example, 3 times U is 3 times U minus V is the vector D, and we can print it. So about the multiplication of a scalar and a vector, it's easy. As we said here, we just have to take, for example, the scalar as R or as C, or even as number, as we had it here. And then we can multiply the scalar with the vector with the multiplication symbol here. About the dot product, the dot product, as Arnisa said, is the sum. There are two ways to find the dot product. It's the sum of the multiplication of the corresponding coordinates for example, between the vector u and v. But also we can find the dot product between two vectors as the multiplication of the norm of the vector u, the norm of the vector v, and the cosine of theta in this case, where theta is the angle between two vectors. But it's easier here because we have two previous vectors, for example, u and v, and we are going to print the dot product between these two vectors by using the dot product from the library NumPy. So here it's easy. We can change the vectors. It doesn't matter the dimension here. We just have to create them previously, or we just have to take these vectors from a data frame or somewhere where you have your problem, and finding the dot product is easy from the np dots. About the cross product between two vectors, as we know, the cross product between two vectors is a vector. And there is also two ways to find this the cross product here. The first one is with the determinant, and the second one is with the norm of the vectors, the sign between these two vectors and the vector n. But as I said, we do not have to think about it. We can just use the dot cross function from the NumPy. We have two previous vectors, and then we can definitely print the result. And we know that the cross product between two vectors is the vector, and this is the result. From the dot product and the cross product, we saw that in this formula here and in this formula here, where we can use the sine and the cosine of the angle between two vectors, but there is also an equation, let's say, or there is also a function behind that where we can find or identify the angle between these two vectors. For example, we have two vectors, and from the scalar multiplication for these two vectors, we can, for example, find the cosine of the theta, which is the angle between these. So the angle between these vectors, in this case, found in radian, is this one, 0.39. But there is definitely another function for using the same concept, but just having this the final result in degree, which is np dot degree. So this is just a short introduction about the functions in NumPy, and presenting or using them in linear algebra basic concepts. About matrices, as Arnisa said, matrices are definitely more complex. There is a set of vectors. We have rows and columns. They are very important to identify and to do math operations with them. In this case, we can identify, or we can create a matrix as a set of vectors, as I said. For example, in this case, we are going to add here as the first row of a matrix, but as a single vector. For example, this one is the first row, and then this one is the second row, and then the last one is the last row. And definitely the space between the elements is going to be, let's say, the space between the columns of the matrix. It's very important, for example, to identify the some specific elements of a matrix. So we can here print the A1, 2, which means we are going to print the element in the first row in the second column. But something which is very important here is the fact that when we are trying to count the columns and the rows, we know that in Python, we count from 0. For example, this is the 0 column, this is the first column, this is the second, this is the third. And then this is the 0 row, this is the first row, and this is the second row. So we count from 0 just for indexing the elements. For example, 1, 2 means that we are in 0. This is the 0 row, this is the first row, and we are in 1, 2, 3, or 0, 1, 2, 7 is the element corresponding to the 1, 2 coordinates. Definitely we can print the shape of a matrix, a.shape. You are going to see this in different data frames in Python. If you have a table with the function .shape, you can print the shape of the table. The transpose, it's easy. The matrix A.T, we have here the transpose matrix. And AT is now a new matrix. We can identify its shape too. And scalar multiplication for between scalars and matrices, definitely a scalar multiplying a matrix means that this scalar is going to multiply every single element of the matrix. And here we have, for example, for the given matrix that we have, before we have here 2a means that we are going to multiply every single element by 2. And this is the result. About the addition and the subtraction, these are easier. Here also, for example, if we have another matrix B, we can declare it even here as an array, as you can see, but you can declare it as we have the one here. So it doesn't matter where is the row. You can have all the rows in one row, but you can also have them ordered as we have presented the matrix A. So for example, if we have now the matrix B and the matrix C, we can have the sum of them A plus B, or A minus 2 times B, or B minus A, or for example, B minus 2A. It doesn't matter. You can create an infinite combinations between matrices and scalars. About the multiplication, we are going to multiply, for example, two matrices A and B, and we said that the dimensions of the matrices are very important because we are going to multiply them if and only if the inner dimensions are the same, which means the number of the columns for the previous or the first matrix must be the same with the number of rows for the second matrix. So in this case, the multiplication between two matrices is A, is this symbol here, A, I forgot how it's called now. A, C. So
At.
this is at. Oh my God. A at C means that we are going to multiply the first matrix with, or A and C matrices together, or C and A. The determinant, it's easy too, because for a given matrix, we are going to find the determinant from the functions from the linear algebra directory, which is the dot function. So for example, for the given matrix D, we are going to define the determinant as NP linear algebra, let's say directory dot that's D. So the inverse matrix, there are some conditions. It's a square matrix and the determinant is different than 0, but it's easy after checking this that the inverse matrix is, as I said, NP linear alg dot INV D for the D matrix that we had before. In this case, as we know, D times the inverse matrix for the given matrix D, the result is going to be the identity matrix. So definitely we do not have any thing new here because we know the multiplication of the matrix and the corresponding inverse one. So, about the system of equations, as Arnisa said, there are definitely so many ways to solve them, but here in linear algebra, we know them as AX equal B. This is the classic one, but in this case, we are going to solve, for example, we have the matrix A, we need the matrix, we need definitely the vector B, we are not considering, for example, the axis. We just need the number of how many variables do we have, the number of variables, for example, 3 variables, 4 variables, it doesn't matter. The equations or the functions are wiser to know or to identify the number of our unknown variables that we have here. There are many ways to solve them, but for example, in this case, if we identify the matrix A and the vector B with Python, we are going to solve this as function or based on the function that solve from the same director. And the X is now this vector here with 3 solutions, which means, for example, for x1, x2, and x3 or x, y, z. So there are also some other let's say rules. For example, the Cramer rule for solving the system of equations. In this case, we are going to use the determinant, for example, for the matrix A and for 3 other matrices based on the number of variables that we have. So we are going to identify them first, what is the AI and how we are going to replace the column, the ith column with the vector B, and then we have here the solution as the fraction between the determinant of the AI matrix over the determinant of the matrix A. The result here from the Cramer rule is this one. So this is just a very short introduction about some libraries, functions, the way how can you write matrices. It's very simple, easy, and definitely everyone can do them. And I think that you are definitely going to do more than this in your problems, in your modeling. But we wanted to share something that linear algebra, it's not always with a pen and a paper in a table, but there is easier, it's much easier in softwares and programming languages. So I'm just stopping my screen sharing here, and thank you so much, everyone. And please, if you have any question or something to say, feel free. We would love to hear from you. How did you find this lecture? Okay, time wasn't enough, but how can you describe it? Do you have something to say?
We encourage you to put your hands on programming and
Yes.
to see all these results by yourself. You just need to have the softwares and you can do all these performances, operations, math operations.
And something very important is that R and Python are for free. So you don't have to pay. You don't have to have something very specific to use this knowledge in an environment that you might not have, for example, for another software. But you can check them, you can test them, you can try them. And there are so many more libraries where you can learn about the data, about linear algebra, about more complex knowledges and applications. So I think that if you can look something, for example, for a library or for a function or an application, you can find it. And feel free to contact us anytime.